Hello class. Good morning. Hello Mohammed, Amina, Nicole and Salma. Welcome. Thank you for being here on time. Okay. So today we are going to discuss. We are going over any questions you might have about the review and the test one material, and we are going to discuss final project rubric. Exactly. Okay. So the first thing that I want to go and do let's go to Blackboard. On Blackboard, I have posted yesterday. I posted the final project review, but today I finished all the items that of the final project in Blackboard. So we are going to click on our classroom, final project folder. You enter there, and the first item is where you are going to submit your final project. Okay, in this item there is also the rubric of the final project. That's what we are going to do. That's what we are going to discuss today. You are seeing three more items below that: final project check number 1, final project check number 2, and final project check number 3. These are in the check number 2 and check number 3. They together are combined for a 50 point worth in your final class grade. Okay, so today our first final project check is just to represent the rubric, to go over some technical aspect. How I like to write math is in word processor, and I like to do a little bit of vector graphics. That's something that is going to be extra. If you want to learn a little bit of vector graphics, we can do that today, but it's not required for you to do it. So remember that we are creating a digital paper, a digital work. What I want you to be able is to first write math in your computer or your device, or write math in pencil and paper, but you need to be able to publish that project online or in a digital way. So the easiest way to do that is by creating a PDF document. All right. So let's jump to the review, to the rubric. You're going to click here, and this is the rubric that we are going to that I'm going to use to evaluate your final project. The final project is a replacement for the final exam. Okay, so we are not taking a final exam. We are creating a final project that is worth 250 points of the class. Okay, exactly the same of it would be for a final exam. Okay, and I'm going to evaluate your project on two main components. In general, the document itself, that is taking into consideration the whole document. Okay, and I'm going to be evaluating the content per test that is going to be included on your project. Okay, so each test content is worth 25 points. Okay, in total is 100 points. For the document in general, I might use this. I think this is better. Okay. For the document in general, what I want you to do first is to follow the format. Okay. If you don't follow the format, I'm not going to accept your project. Okay. It doesn't matter if it contains everything that I'm asking for. If the format is not the one as I stated, I'm not going to accept your work. Okay, and the format is very easy. It's going to be one PDF document. Pages must be portrait orientation, ordered, and they need to include the page number. This is something simple. You can do this on the first page. Must include student, instructional, and class information. Okay, that way I can identify who project is and to what class, or this is something that is more technical because I know that I am the instructor, I know the class information, but that is something that looks nice on your project. So you need to include your information, my information, and the class information. Good math writing, that is something that we are going to be working during the whole summer. That is why we have 2 more check, because I want to review your math writing in digital, and I want you to give you advice and feedback in order to be able to write appropriate math in a digital document. Okay, and clean and organized. Okay, I'm going to assess something that is organized and clean, that it looks nice. So that is the format. Something very straightforward, very easy to follow. Okay, if you don't follow this format, then I'm not going to assess your project. Okay. Like I said, here you have more information, more details. The final project is worth 250 points. 150 points correspond to the whole document. 100 points distributed across the 4 tests, 25 points each. Okay, so how much you should read per test? And let's go to the content table. I'm expecting you to write 2 to 3 pages per test. The draft that I wrote for you is something that is going to guide you and is going to tell you how I like math in digital, how I write math in a word processor. Okay, but I'm not expecting you to write 30 pages per test. No, I want this to be something that you feel comfortable writing this project, creating this project. Okay, because this is for learning. This is maybe your first time writing math in the computer, and I want you to feel comfortable and confident with your work. So 2 to 3 pages is what I'm going to expect from you for each test. If you want to write more, you are welcome to do that. Okay, but if you stay to 2 to 3 pages, you are going to do good. Okay, so in terms of the content, test number 1, you saw that we discussed very precise topics, very specific topics, not all the topics that are included on the draft. Okay, so those are the topics that I want to see on the content of test number 1. Okay, if you include all those topics that we discussed, then you will get the 25 points. What are those topics that we have discussed? Transformations, piecewise defined functions, identify the parts of the function, and if I'm not mistaken, evaluating symmetry of the relation algebraically. Okay, I think those are the 4 topics that we have focused on test number 1. Okay, so those are the topics that I want to expect to see on test number 1 part, the content that I want you to put on test number 1. All that is on the draft. So you are going to take the draft, and then you are going to identify where I talk about those topics, and then you're going to start editing it. The draft is for you. I don't want you to lose the draft because the draft contains more information. Okay, but your work should be focusing on transformation, functions, piecewise defined functions, and symmetry algebraically. Okay, so that means that you are going to now then go to the draft and you're going to edit it. You're going to erase all those topics that we didn't discuss per se in class, and you're going to just focus on the one that were discussed in class. Again, 2 to 3 pages. You don't need to write too much for test number 1 because I have written everything there. Okay, everything needed is written there. The only thing that you will do is to maybe edit some wording, maybe use your own words on what I maybe using your words on the project, but that's all. Okay, there's no much to worry for test number 1 because you already got there. The only thing that I want you to do is to start with like getting used to Word, how to edit Word, how to work with the word processor. Okay. Starting on Friday, we're going to start with test number 2, and then I'm going to give you a class more structure where I'm going to go. This is topic number 1. This is the one that we're going to discuss, and then I'm going to give you the definitions, the examples, and those example and definition and topics that I'm going to be presenting are the one that I want to see on content number 2, on the content of test number 2 on your project. Okay, all those classes are going to be recorded. So that means that if you miss something, you can go back to the YouTube channel and review and make sure that you are including everything, each topic that is presented in class. You can make sure that you are including them on your project. Okay. Yeah. Test number 1 is going to be a take-home test, and it's going to be available on Blackboard next Wednesday. Okay. Any question with this part? Yeah, that's a good question. Okay. In terms of what exactly you are going to be writing, you have the freedom to decide how do you want to write the information that I'm going to present in class. If you want to write it exactly as I am presenting the information in class, that's good for you. That's good for me as well. Okay, but I want you to start thinking of how you want to present that structure. Okay, yes, you are going to use definition because I'm going to present definitions, and you are going to follow the topics that I'm presenting, and then you are going to write based on those topics in your project. Okay, now, but maybe we are going to be talking about let's say 5 to 6 topics per test, right? That's an example. I'm not expecting you to write example of each topic in the project. What I'm going to look for is at least 3 well-chosen and well-chosen examples per test. Okay, so in that part, you are going to decide which are going to be the examples that you want to put on your project, and which are those examples that will help you to understand and to grasp more the topics that we are discussing in class. Okay, keep always this in mind. We are working with an open book, in an open book environment, so all the assessment, for all the assessment you are allowed to use your notes. So your project is like your notes, is the notes that you want to use for the assessment, for the quizzes and for the test. Okay, so in that term, you have the freedom to decide how you want to write the information that I'm going to be presenting. Okay, so it is not something that I just going to tell you, write this, write this, write this. No, I'm going to present information, and you are going to decide how you want to present that. Does that answer your question? Okay, so this table here in general is where this part of the project is the document in general, and is worth 150 points. Okay, and here this is how I'm going to evaluate your project in general. I'm going to check for your presentation, so I want to see something nice, something that I can understand. The grammar need to be correct, topic need to be identified, fully explained and very easy to follow. Okay, there should be an organization in the project. You can think of this as how friendly is the project. If I start seeing your design, the way that you have wrote and construct your project, is that going to affect the way I'm going to understand what you wrote there? Okay, so this organization of the project is more how friendly is your project, how nice it looks to, and how anyone can read your project and understand it easily. Okay, so the presentation is exceptional in terms of neatness, design, and layout. Okay, then we focus on the math part. Okay, mathematical representation, equation, diagram, graph, table, etc. Okay, representation are clear and appropriate, with explanation of significant elements. Okay, if you are writing a procedure of how to solve something, and a specific problem in math, I'm going to expect you to say, this is step number 1, this is what we are going to do in step number 1, this is step number 2, step number 3, something that I can follow easily, that anyone can follow. Okay. Mathematical procedures, I want to see those mathematical procedures that are explained without difficulty and with full explanations. Okay. Mathematical operations, this is where we are going to focus if your numbers and operations and your calculations are correct, are clear, and logical. Okay. If you have numbers or calculations that are incorrect, then you are going to start losing points in this criteria. And then the example. How many examples I want to see per test? 3 at least. You can add more if you want, but if you at least select 3 well-chosen and well-sequenced examples, you are good for that test. Okay. So this is the rubric that we are going to be using. It is available on Blackboard. How do you access there? Click on my classroom or our classroom. Click on the final project folder, and then the first item it contains is the first item is where you are going to submit your final project. It is due on August 8th at 11:59 p.m. Okay, so on August 8th you are going to click here, and then you are going to submit your project here. Okay. In that time, before we get to August 8th, so we are going to do the first check, which is today. This is not assignment, so there's nothing to do here. What I want to do on the first check is to discuss the rubric and the expectation for the project and to answer your questions. On final project 2, you are going to submit your first draft. In your first draft, I want to see the content for test number 1 and test number 2. Okay, this is important because here is where I'm going to give you the feedback. I'm going to provide you with feedback. I'm going to tell you if you are doing good or if you need to improve on something. Because when you submit your work, I want you to have a perfect final project. Okay, I don't want you to submit something incomplete. What I'm expecting from you is you to earn all the points for the final project. Okay, that will depend on you, on your work, but at least I'm going to give you 2 chances to submit your draft and to receive feedback from me. Okay, so each check number 2 and check number 3, each is worth 25 points. In total is 50 points that goes to your course grade. Okay, so careful, you need to submit by July 11. Okay, if you submit late, it's not going to be accepted. You are going to score 0 points, and I'm not going to provide you feedback if you submit late. So I want you to submit on time so I can plan that week and give you the appropriate feedback. Okay, the same for final project check number 3. On that one, we are going to cover test number 1, 2, and 3, and we are getting ready to submit your work. The only test content that I'm not going to review is for test number 4. But before August 8th, if you want to if you want me to review your test number 4 content, you can send me your draft via email and I can provide you with feedback, okay? But the only 2 checks that we are going to do that are worth points are check number 2 and check number 3. On those days, you are going to submit your draft, I'm going to review your work, and I'm going to provide you with feedback, okay? Any questions? Okay. I wouldn't like, but I can show you what we do on 1146. It's more extensive, it's a complete portfolio. But since this is the first time that I'm adapting 1148 to summer, I don't have exact example from previous student. So in that case, I cannot provide you with the example. The best I can do is to show you the draft. Okay. So, and this is something that represents what I'm expecting from you. Not exactly with the design and the graphics, no, but something that I can read and follow. Okay, this is the example that I have in hand right now is this draft. That's why I wrote the draft before class. Okay, so yeah, the answer is no, I don't have previous student examples. Say one more time. Oh yeah, it is already on Blackboard. In our classroom, you click on MATH1148 draft, and there you have 2 versions. You have the PDF version. The PDF cannot be edited, but you can download the Word version, which then, this is the one that I want you to start using, because here you're going to start editing. Here you can erase, you can change the wording, you can copy and paste the graphic. Okay, so you have this document available there. Correct. Let me go through an example that I did on the draft. All these are examples, but let me see if I can see one that looks more like let me see if I can go. Okay, so we have discussed these examples. Exercise number 1, 2, and 3. Those are the exercises that we did for transformations. Okay, so this is a good reference of the type of example that I want to see from you. It's an example that almost covers everything discussed in the topic, and it's an example that will help you to as a resource when you are doing the assessments. Okay, so in page 26, 27, and 28, there are a type of example that I'm going to expect from you. A well-chosen, well-sequenced example. Okay, and you are going to choose only 3. Okay, you don't need to select a sample of each topic. Other examples that are good, the piecewise defined function. This is a good example. How to graph a piecewise defined function, page 30 and from page 30 to 32. Because you are seeing here how I wrote all the steps. Okay, here I wrote all the steps. This is a good reference as an example to use for your project. Okay. Any other questions? Okay, how do you feel about the project? Do you think it's something that is going to be difficult for you to do or not? This is difficult? Okay. So if you feel that it's difficult, so when that is the case, I want you to be able to, I want you to communicate with you during the whole summer. If we finish the class, you are going to ask me, Eric, what do you want me to write on the project from today's class? And then I'm going to guide you. Okay, pay attention on this part. I want this detail on the project. I want you to write about this. This is a good example. Okay. After each lecture, please ask me what from that lecture I want you to present. Okay, or what from that lecture is going to be more important for your project. Okay. So there is something that we need. We need a word processor in our computer or device. If you are planning to write and type the project, then you need a word processor. Anyone who is having technical difficulty with getting a word processor, all of us, we have access to the Office software. It is a free access because we are part of Columbus State Community College, and with that account we have access to all Office software. In Office software we have the word processor. Okay, anyone who needs help on getting the word processor? Okay, perfect. So after I finish discussing what we need, you are going to stay in class, and then I'm going to guide you. Are you working on a cell phone? Okay. Do you have a computer? Do you have access to a computer? Say one more time. Okay. So we can do other things. You can do your project in handwriting. Okay, and then you can scan your handwriting, and then you can submit a PDF from there. Yeah. What's your name? Because I don't have your name here. I only say one more time. Okay. Yeah. Thank you for being here. Yeah. Okay. You are going to be working from the iPhone the whole summer, right? Okay. So then I need to show you because if you choose for the whole class, you will have the freedom to decide if you want to do your project in digital or if you want to do a handwriting and then scan your work. Okay, that is going to be up to you. Whatever works best for you. Okay, if you plan to do a handwriting, okay, so we need to practice how to scan your papers and how to create a PDF document. Okay, we did that on the previous two classes. Okay, we did that with the practice of how we should submit a PDF document, and we did that with the quiz. Okay, but if you need more practice, I will be happy to continue practicing with you until you understand how to properly submit a PDF document. Okay. All right. What else do we have here? So this is Word. How do I write math in class? In Word is I click on Insert, and I click on Equation, and then I start seeing this box here. In this box, we can start writing equations. They are codes to write math, and I don't expect you to know those codes. But if you are interested on learning those codes, let me know. I have a document with all the codification so you can present your work properly in Word. So that's one example. Let's see another example how I wrote fractions. Okay, so I type that, open parentheses, 7x plus 3, close parenthesis, /11. So this is a fraction, right? So because I'm writing inside a equation box, when I go outside the range of what I was typing, it converts my writing into a math writing. Okay. For this, if you are interested in learning how to write this, you will want to meet with me and to practice this, because this is going to get you a little bit of practice. That's why we have 2 more checks, check number 2 and check number 3, so I can review your math writing in digital. Okay, let me see if I can get you an example of a handwriting that is going to be accepted in our class. Okay, as you know, Pinterest is a place where people share like ideas. Okay, this is Spanish, so this is not math. I'm looking for math. Let me see if I can get a math example. All right, so this is not exactly a math-related concept, but this is something that I will accept as part of your project. Okay, something that it has a design, it looks nice, it looks organized, there is personality there, and also there is the math content that I'm looking for. Okay. This is a good example of if you decide to do handwriting in your project, you can do a handwriting, you can do that, but you need to be able to present something that looks nice, and you need to be able to convert your papers into one PDF document, which is scanning your documents, and as we did for the practice and for the practice of how you submit, you should submit your work, and the quiz number 1. Okay, and we are going to continue practicing as well that on the next quiz you are going to do the same. You are going to work on paper, you are going to scan it with your cell phone or any other device, and then you are going to convert all that into one PDF document. So this is a good example if you decide to do handwriting. Okay. Any other questions? Okay. There's before going to that, any question regarding the project? Yes. This is another example that I found here. Again, it contains personality, it's organized, it's clean, it's nice. This is another option or another style. If you go to Pinterest, if you like design, you can go to Pinterest and you can like put in math study guides, examples, and you're going to see these pictures. Okay, you can use this picture as reference to create your project if you plan to do handwriting. Pinterest. Let me put it. That is the page. Okay. Also, I should download this and maybe post it on Blackboard as an example. Okay. Any other questions? Okay, so how to write. If you want to go a little bit extra with, yeah, Sam. No, in my MATLAB, what you have is access to the book of the class and more exercises. Okay, so if you want to continue practicing what we are discussing in class, you can go to MATLAB, and there you have more practice and more resources. Okay, if you want to go a little bit extra with your project, I do a little bit of design. And this is obviously using math as well. You need to have some kind of idea of how to use this. So I can take a few sections with you to show you how to create vector graphics. This is used for logo, yeah. So it is a free software. Let me see if I can. So all what you have seen. So this is, yes, it's used for logo. So this is my dog, for example, and I created a logo based on my dog. Okay. Let me see if I can show you. So this is the canvas where I create all the graphics for our class. Okay, all the exercise that you see on the graph. So I create them here. Okay, but this is going to be extra. If you are interested in design, if you think that in your future you are going to do some kind of design, just let me know and we can separate some sections to start like learning how to do vector graphics. Don't save. Okay. Any question before we go to the review? All right. So then, questions about the review. Which page, which exercise do you want to do? The practice. Okay. What do you mean? The solution of what I did. Which one you are talking about? The quiz? Okay, so are you asking me if I save the notes for? Yes, these are the notes. Yeah, always the notes are always on my computer. Yeah. Okay, so let me find that document practice. So let's go and do the practice. Let me put it here on my. Okay, this software that I use as my notebook is a software that is also available for you with the Columbus State Community College account, because this is part of the Office program. Okay, so practice. Here is practice. So print out. Okay, so you tell me number of the page and number of the exercise. You there? The practice. You're asking for the key. Yeah, I don't have the keys for this one particularly. So what I'm going to do with practice is by you requesting me what exercise do you want to see. No, I don't have the key for this one. Yeah, I'm not going to post the key for the practice, because it's going to be very similar to the test. This is the format of the test. Okay, so I want you to take the practice and you write your own key with the practice. And you just, the only thing that I'm going to do with the practice is if you request me to check your answers or your work, I could do that. But for the practice, I'm not going to post any key for the practice. So we have about an hour and 20 minutes to continue working with the practice. Just let me know which ones you want to go over. Yeah, right now, is there no question regarding the project? If you have access to the rubric, you are free to go. The time that we are going to spend here is more practicing, getting ready to for test number 1, okay? All right. Before anyone to go, remember that today you should be submitting your review for test number 1. Okay, and that is going to be graded based on completion. Review are going to be graded just based on completion. Say one more time. It is due today. The review is due today. Yes. Review, practice. You are allowed to ask questions about everything. Do you have any questions? Okay. I have it here. Which page? That's a good question. Okay. All right. So when finding the domain of the function, and the only thing that we have is the equation of the function, we need to first know if that equation has any type of restriction. Okay, and what are those restrictions? Let's focus on this function here. This is a rational function. It means that we have a numerator and a denominator. Okay, so we have a fraction here. And then my question will be, do you know what is the value of 1 over 0? Is this something that we get a value, or is this something that is going to be undefined for 1148? It is undefined, okay? So in our class, we have this as, let's put undefined, okay? We don't have, since we are working with real numbers, if we divide by 0, it's going to be undefined. Okay, so this is the function that we have. And it is a rational function. It has a denominator. So what is the restriction here? That the denominator can I grab this? There's a restriction here, and is that the denominator can't be 0. Okay. So based on that restriction, we can identify the domain. Joanna, yes, the review, you can work on paper and then submit the paper as one PDF document. Make sure that all the exercises are labeled and identified. Yeah. Okay, so what we don't want here is that the denominator cannot be 0. So we take the denominator, x minus 3 can't be 0. Okay, and then we solve this for x. So what we do to solve for x, we add both sides by 3. Okay, and we cancel this part here, and then we have x can't be equals to 3. So there is here a restriction, or the value that x cannot be is equal to positive 3. So the real numbers goes, okay, real numbers go from negative infinity to positive infinity. But in this situation, we have a restriction that x cannot be equal to 3. So the domain of the function is going to have a modification of the real numbers. So the only number that is excluded here is positive 3. So we are going to write the following: from negative infinity to positive 3. We are not going to include positive 3. So 3 is going to be a boundary. Union, we start at 3 again and then go to the positive infinity. Okay, so that is the domain of R of x. Okay, we modify the interval of the real numbers based on the restriction that we have. So we have a restriction, denominator cannot be equal to 0. So we check which value of x makes the denominator equal to 0. That value is 3. And then we modify the real numbers to have the domain of the function. So from negative infinity to 3, union 3 to positive infinity. Okay? This equation here doesn't have any restriction. So the domain is from negative infinity to positive infinity. Okay? What are going to be the restriction, or which operation contain restrictions? Fractions. We cannot have a 0 in the denominator. We have another one operation with a restriction. What is that restriction? Before I move to C, any questions so far? Okay, so then when I move to C, I have a square root here. And the square root contains a restriction. What would be the value of square root of negative 1? Say one more time. That's an example. I'm just asking you, what is the value of negative square root of -1? Do you have a calculator there? Okay, so let's use this calculator. So let me check first if the square root is working. So the square root of 4 is 2. Okay. So let's see, the square root of +1 is 1 as well. Okay. Now let's erase all this and let's put -1 and take the square root of this. And it says invalid input. Okay. So this is going to give off the restriction. This is invalid, right? Or undefined at this moment because we are working with the real numbers. So there is a restriction here. The square root or the radical has two parts, the radical and the radicand. The radicand is anything that is inside the radical, okay? The radicand. So the restriction is that the radicand, I think radicand is spelled this way. Let me double check that. Okay, radicand can't be negative. Okay, cannot be negative. Oh, so what are we going to do here? So we are going to take the radicand, which is -2x, okay? And we are going to use inequalities. Inequalities in this case is going to be, we are looking for greater than or equal to 0. 0 is allowed, square root of 0 is 0. 0 is allowed in the square root, in the square root, because we can get a value out of the square root of 0. But when we are working with square roots, the radicand need to be greater than or equal to 0. So we use this inequality to solve and solve for x. When we solve for x, we divide both sides by -2. Okay? When we are dividing here by 2, we cancel this 2 negative. In the inequalities, if there is a negative, the inequality flips. So then x needs to be less or equal than 0, because 0 over -2 is just 0. So the domain here is going to be, we are going to translate this into an interval. And this is from -infinity to 0, and we are going to use a square bracket because we have an equal sign here. This here includes 0. Okay? So those are the two restrictions that we have when we have a fraction or when we have a radical or a square root in this case. Okay? Any question with this? Okay? D then is going to be a combination. Okay? You have the two restrictions here. You have a restriction here and you have a restriction here. In the denominator, you are going to get that x cannot be equal to 0. In the numerator, x plus 1 need to be greater than or equal to 0. And based on these two restrictions, you are going to evaluate or identify the domain of that function. Okay? Next questions? Okay. Which page? Yeah. Okay. So we have the graph of f, okay, and we have a transformation, right? And we need to graph p of x. P of x is based on f of x. The first thing that we are going to do is to identify the key points. The key points are those points that are important for the shape of the graph. So we have this triangular shape here, okay, upside down and down. So up and down. So we have 1, 2, 3, 4 key points. 4 key points is all what we need to draw. 4 points is all what we need to draw this graph, or the shape of this graph. So we have -3 and 2. That's that point. We have -2 and 3. We have 0 and 0. And we have 1 and 1. So all those are my key points. Okay. Next, we need to identify the transformations. So what I'm going to do is to write here p of x is equal minus f 1/2 x plus 2. Okay, and from here I'm going to identify the transformations. So the first transformation from the input group to the output group is going to be a horizontal stretch by a factor of 2. Second transformation is going to be a vertical reflection. Okay, remember vertical reflection is about the x-axis. That comes from the negative. 1/2 times x is the first transformation. And the third one is up 2 units. Any questions so far? Okay, then the operation that taking place in the coordinates. So we have the x coordinate and we have the y coordinates. Okay, anything that is horizontal will happen to the x coordinates, and anything that is vertical will happen or will affect the y coordinates. These two are vertical, this one is horizontal. This description will tell us what to do with the x coordinate. Horizontal stretch by a factor of 2 means that we are going to multiply all the x coordinate by 2. Vertical reflection and up 2 units means vertical reflection means that we are going to multiply by -1 all the y coordinates. Up by 2 means that we are going to add 2 to all the y coordinates. But we have an equation because we have two vertical transformations. So we have -1 times y and we have +2. Okay, so we need to combine those two transformations into one equation. Any question? Then we are going to we have the key point of f, so those are the key point of f, and then we need to have the key point of p of x. And using these operations is how we are going to, can I grab this? So using these operations, how we are going to transform or convert or modify the coordinates. So I know that all the x coordinate of f need to be multiplied by 2. So I have -2 times -3, that gives me -6. -2 times 2, that gives me -4. 0 times 2, that gives me 0, and then 1 times 2, that gives me 2. Then I'm going to take all the y coordinates of P, and then I'm going to multiply them by -1 and then add by 2. 2 times -1 is -2 plus 2, that gives me 0. -3 plus 2, that gives me -1. -0 plus 2, that gives me 2. And -1 plus 2, that gives me 1. So those are the key points of P of x. Next thing that I need to do is to plot those points into the graph. So I have this coordinate here, this plane here. So you are going to use that plane. And we are going to plot those points. So I think I can just grab this. Can I? I don't think so. So -6 and 0, we have it here. -6 and 0. Remember always to label the points so I know the coordinate of that points. -4 and -1, it is here. We got this one. 0 and 2 is this one. And then 2 and 1, it is here. I got this one. Connect the points and make sure that the graph looks, that makes sense with what we got. Questions? Okay. Any other exercise that you are interested in? Okay, Jacqueline, which one do you want to try? Jacqueline, ¿cuál ejercicio te gustaría trabajar? Tranquila, tranquila. Mm-hmm. Mm-hmm. Okay. Okay, this is from the review, exercise number 32. Okay, remember that for piecewise defined function, we have pieces. Piece number 1 is this one here, and piece number 2 is this one here. What you want to do, Jacqueline, ¿estás bien con que lo explique en inglés? Okay, so what we want to do is to go for all the steps to draw each piece. So for piece number 1, step number 1 is going to be identify the function. This one is just 0. When we have just a number, there's no variable, so it is a constant function. Okay, and then identify the number of key points, we need to draw a constant function. If you go to the library of parent function, you will see that a constant function is just a horizontal line. So that means that we will need 2 points because it's a line. A constant function is a line, a horizontal line. Okay, so the shape is important. Knowing the shape of the function is important to get the number of key points. Step number 2 then is going to be to know the boundaries. So what we have that x is going to be less than 2. So we need to transform this inequality notation into an interval notation. And the interval notation here, it says x goes to the left, or x goes and is always less than 2. So that gives me that the left boundary is a negative infinity. I use in parentheses here because infinity is not a number, it's an expression. And then the right boundary is 2. But this is less than, okay? It means that we are just using 2 as a reference value, but no, it's not included. So that's why I use a parenthesis. Step number 3 is going to be based on the boundaries. So I have, this is the interval for piece number 1. I know that I need 2 points. From the left boundary, which is infinite, I cannot get a point. So that tells me that I need to find another value that represents the left boundary. Okay, so the other value that I can take here, well, if I have the opportunity to take 0, I'm going to do that. So this interval includes 0. It's from negative infinity to 2. So I'm going to take x equal to 0, and then the equation for y, because this is a constant value, the equation for y is just y equal to 0. So y equal to 0. So this is the point 0, 0. And this is going to be included because I'm taking a value inside that interval, but I'm going to use an arrow because I have an infinity there. The left boundary goes to negative infinity. Then the right boundary, it is not included. Okay? Even though it's not included, I'm going to use x equal to 2. Okay? Knowing that this x equal to 2 is not included, it's not part of piece number 1, but I'm going to use it for location. Okay? When it is not included, I'm going to use it for location only. Location. So the equation again is going to be y equal to 0. Why? Because it's a constant function. So I have 2 and 0 here, and I'm going to use an empty dot because it's just for location. It's not included. Okay? So those are my 2 points. Because the shape is a line, I don't need to do an extra step to find another point. So with those 2 points, I can place those 2 points now here. So I have the point 0, 0, and I have the point 2. This grid is not defined. The value of those grids are not defined, so you are going to define those grids. I'm using each line as 1. So 2, 0, and I know that this goes to the left. So that is piece number 1. Piece number 2, I'm going to repeat the same process. Piece number 2, I'm going to do it here. Step number 1. Again, it is horizontal line. It is a horizontal line because it's a constant ID. It is a constant function. So the shape is a horizontal line. How many key points do I need? 2, because it's a line. Step number 2, the boundaries. What I have is x needs to be greater than or equal to 2. This in interval notation means from 2, okay, x is greater than 2, from 2 to positive infinity, equal. So we use a square bracket because we are including 2 there. And there is the parenthesis for the infinity. So that is the right boundary. It goes to infinity. Step number 3. So we go here. This is left boundary. This one is included. X is going to be 2. Y is going to be based on the definition of that piece. So y is going to be 1. So the point is 2, 1. It's going to be a solid point because it's included. Right boundary is infinite. So I'm going to select a point that is in this interval. So anything that's greater than 2, I'm going to select 3. Y is going to be 1 because that's the equation of y. So that gives me the point 3, 1. It's going to be a solid dot, and I'm going to use an arrow. Okay. This point is an open circle. I made a mistake there. I put a solid dot, but it is an open circle. Then I go for piece number 2. So piece number 2 is 2 and 1, and then 3 and 1, and this goes there. And that is the graph of that piece. Jacqueline, any question here? Sé de qué está hablando. I know what you're talking. Let me find the exercise. I think. I think we could do this one. Is it? Okay. So Jacqueline asking about E and G. Is that correct, Jacqueline? Okay. So let's start with positive regions. So positive. Okay. So let's identify the positive region here. Okay. So how are we going to answer this? We are going to answer this by the x coordinates because we are going to give location. Okay. Jacqueline, nosotros vamos a responder a estas preguntas usando los x coordinates porque vamos a dar localización. Okay, localización. Okay, positive if anything that is above the x-axis. So The only region that we are seeing that is positive here of the function is this one that I'm painting in blue, and we are seeing an arrow here. Okay. So what we are going to do first is to identify from which x value it starts going above the x-axis. Okay. So vamos a identificar el valor de x donde la gráfica empieza a irse hacia arriba, por encima del x-axis. And that value is 2. It is here. So I'm going to start with 2. Remember that I'm going to write an interval. Okay, vamos a escribir un intervalo. At 2, exactly at 2, at x equal 2, the value of the graph or the value of the function is 0. Okay, at 2 we have an x-intercept. Okay, so that is the reason why we are not going to include 2 as part of this solution. Okay, the function has a value of 0 at 2. It is not positive. We are using 2 just as a value of reference. Starting from 2 is where we are seeing the positive value of the function. Okay, Jacqueline, exactamente a 2, cuando x es igual a 2, el valor de la función es 0. Entonces, a partir de 2 es que vemos la gráfica que va subiendo hacia arriba. So, 2 lo utilizamos solamente como un punto de referencia y por eso utilizo paréntesis, para no incluirlo. Okay, and then the arrow tells me that it continues up and right, so it goes to the positive infinity. Okay, the arrow always goes to the infinity. If it goes to the right, it's positive infinity. If the arrow goes to the left, negative infinity. Okay, negative regions. So negative region is anything below the x-axis. So we are seeing, okay, and we need to give this an interval. So negative from left to right, we see that the arrow goes to the left, so it starts at negative infinity. We do not include negative infinity, okay, because it's an expression, not a value, comma, and where we stop? At 2, exactly at 2, but we do not include 2, because for the same reason, at 2, the value of the function is 0. And then we are going to give where the interval on which f is 0. This is the same as the x-intercepts. Okay, and here we are going to answer by the value of x. Why? Because these are just points. This is not a graph. These are just points. So x equals -1 and x equals 2. You could write it like this, or you could just curly brackets. And that is how you write the location where the value of the function is 0. Jacqueline, ¿alguna pregunta aquí? Any question on item E here? Okay. Say one more time. Oh, okay. Yeah, let me finish with item G and then I'm going to that. Okay. Okay, so now let's do G, which is identify increasing, decreasing, or constant behavior. So let's start with increasing. So we are doing G, increasing, again, we are going to answer, this is location, we are going to answer based on x coordinates. From left to right, anything that goes up is increasing. This one also goes up, that from left to right, we are going up, so that is increasing. So we have two regions that are increasing, this region here and this one here. So let's identify those regions based on the x coordinates. From negative infinity to negative 1, we do not include negative 1 because at negative 1 there's just a point where it changes, the graph changes behavior from increasing to decreasing. So the point is undefined in terms of the behavior there. Okay, from negative infinity to negative 1. Union from 1, again, it is a point. We are not going to include it because there's no definition of the behavior of that point there. From 1 to positive infinity. Okay, decreasing. We have only one region of the graph that goes down from left to right. So decreasing is from negative 1 to positive 1. And that's all that we have of decreasing. Constant. Do we have a constant? Is there any constant behavior here? No. If there is no constant behavior, you can omit it or just put non-constant behavior. Okay. ¿Ya quieren alguna pregunta con esta item? Okay. Okay, perfect. Okay, let's go back to the piecewise defined function. Which part do you want to review? Oh, okay. Oh, yeah. Let me see if I can put it better to you. Can you see this well, or do you want me to zoom in? Okay. Yeah, sure. Okay, perfect. Any other questions? Is that review? Okay. So we want to do this one with the following table. Let me go back to the review and show you which one do you want to use. Where is it? Okay, I know what is it. It is on the draft. Where are the draft? I think this one. Okay, so that exercise is a simplification of this table, but I am using algebra to do that simplification. So sometimes, since it's algebra, sometimes it causes a little bit of trouble. Okay. Okay. So what we want to do here is to identify the transformations based on this statement here. Okay. So what we have first, we have I should have put here that the parent function is f of x. Okay, so we are using f of x as the parent function. What we are doing here is that we are adding by a value of k, and k is greater than 0. So this means that we are adding in the output group of f. So this means that we are doing a vertical shift up. Does that make sense? Okay, so let's go back to this part here. Let me give you an example, a more concrete example. Let's say that we have this parent function, okay, f of x. And then I'm going to tell you, well, let's transform f of x this way. Okay. So we are adding f of x, the function f of x. We don't know exactly what that function is, but what we know is that the parent function is f of x, and we are adding 3 to f of x. So this 3, the transformation that is happening here is that we are going up 3 units. Does that make sense? Is the example helping you? Perfect. Okay. So then, if I tell you, well, let's use another value. Instead of 3, we are going to do the same, but let's say 7. So this plus 7 means, well, now we are going up 7 units. Okay? And we can continue doing this. If I tell you add 100, well, that means that we are going up 100 units. Okay? So the effect of adding something to in the output group to the function is that we are going up that many units. In this exercise here, in this expression, the only thing that we don't have is the actual value of k. The only thing that we know is that k is greater than 0. Okay? So I don't know the value of k, but I know that we are going up how many units? Well, k units. Whatever the value of k is that how many units we go up. Okay? So that is a vertical shift up. So from here you can take this exact wording, you can put up k units or vertical shift up. Does that help a little bit? Okay. So here we have a negative in front of x, so that is going to be a vertical reflection. Okay. You could go and watch the example that we have discussed, or you can use this table. A negative in front of f, it means a vertical reflection. Okay, so we have this, and we got this one as well. We have a times f of x. A is positive, so a is a factor that is being multiplied in the output group. Of the function. So here it is, but we have two different effects. We have vertical stretch or compressed vertically. If the value of that factor is greater than 1, we have a vertical stretch. Okay, so here let's see if there's any definition of A. Is there any definition? The only thing that we know of A is that it's greater than 0. Well, what we are going to do is to put vertical stretch slash vertical compression. Okay, I don't want you to go to the details because I know that you will know the details. If you identify stretch slash compression, you could say, well, it could be a vertical stretch or a vertical compression. That will depend on the value of A. But if you put vertical stress / compression, I will understand that you got this part and then you got that transformation there. Minus K, we go down. So that is that one. Here in the input group, minus H is we go right. Okay. So that is that one. Plus H in the input group, we go left. That is that one. Horizontal reflection. So that is that one. And then we have horizontal stress / compression. And that is that one. Okay. We don't need to be fancy with the wording. Down, right, left, HR for horizontal reflection. That's all I need. And that, and then I'm going to understand what you mean. Okay. Any other questions? Question 16, page 14, is that the review? Is it this one, right? Okay, perfect. All right. So this is it's very similar to the one that we worked already. So we have the parent function f of x, and then we are subtracting the parent function by 0.5. So now we are obtaining the graph of so the graph of f of x minus 0.5, it is obtained from the parent function f of f by shifting. This is the output group, and we are subtracting. Do we go vertical or horizontal? There is a shift. Is that a vertical or horizontal shift? Horizontal would be if the subtraction goes in the input group, like this one. This one is the input group because it's within the parentheses. Okay, but since it's outside the parentheses, okay, the parentheses here, that is the input group. Okay, so minus 0.5 is a transformation that is vertical. It is on the output group, and we are subtracting by shifting down 0.5 units. Does that make sense? Yeah. Let's go back to the examples. Okay, remember those examples. Okay, if we add, we go up, right? If we subtract, we go down that many units, 3 units. Okay, what we have in that exercise is y equal f of x minus 0.5. So we are in the output group, so we know that is a vertical transformation. That means that we go down 0.5 units. Okay, so that is that exercise. Okay, now let's do this exact thing, but in a complete sentence. Let me copy the screenshot of this. Okay, can you read this well? Okay, so this example that I put here, this is the same as this exercise. The only difference is that we have a complete sentence and the other one is just me writing math there. Okay, so the graph of y equals f of x minus 0.5 is obtained from the graph of y equal f of x, so this is the parent function. Okay, so we are modifying this one by subtracting 0.5 to in the output group. Okay, so this is by shifting down 0.5 units, the same that I have here. Did I answer your question? Okay, perfect. Okay, could you explain page 13b to F, please? Yes. Okay. So here, in the draft, there is the formula to calculate the average rate. Okay, to calculate the average rate, to calculate the average rate is going to be the difference between 2 points. Okay, so we need 2 points. So we need the y coordinate of the second point. Let me explain this a little bit better. So we are going to call point 1. Point 1 it's going to be represented by x subscript of 1, y subscript of 1. Okay, the subscript is just to difference the variable, the coordinate x. Okay, we are talking about a specific value of x of x subscript 1. We do not exactly know that value, but we are using the subscript to difference it from any other x value. Point number 2 is going to be x subscript of 2, x subscript 2, and y subscript 2. So those are the 2 points that we have. And the formula is going to be the average rate. It is a formula. Okay, you will see that it is like taking the slope of a line. Okay, 2 points. So we subtract the y values and we divide all that by the x values, the difference between the x values. Okay, from point 2 to point 1. Okay, so we do that subtraction. Second point minus point number 1. Okay. In B, the only thing that I'm giving to you is the x values. Okay, so point 1, let's say that x equals 0 is 0.1, but then we don't know the y value, but we have the function. So what we are going to do is to take the function, we are going to plug in 0 into that into that equation, and then we are getting the y value. So the y value is 0. 0.2, again, we do not know the y value. Well, we take the function, we plug in 2 into x, and this is 4 plus 6, this is 10. So there you have it. And now we use the average rate formula. So 10 minus 0, 2 minus 0, it is 10 over 2. The average rate of that 2 points in that function is 5. Jordan, did I answer your question about item B? I'm sorry, you said page 13. Yeah, page 13, exercise 12. Okay. Would you need me to do the rest of the exercises? Okay, that's okay. Okay, so I'm going to do, let me see, I'm going to do E and F. Okay. E is this, T is just another letter, but it's the same as using X. Okay, so don't get confused by the different letter used. Let's take point number 1. In point number 1, the value of t is 2. We need to know the value of y. So we are going to take, the equation is here. Okay, so this is the equation. We are going to plug in 2 into t. And we are going to get the y value. So 4 minus 4 is 0. So point number 1 is 2, 0. Point number 2. We know t is 5. We don't know the y value. Well, that's okay. We plug in 5 into t. And these are going to give us 25 minus 10. This is 15. So the y value here is 15. Then, now that we have the 2 points, we're going to calculate the average rate. Okay, so 15 minus 0, and then 5 minus 2. Let me use the colors to indicate you where I took those values. And then we just evaluate this. 15 over 3, this is equal to 5. Any question on this one? Jordan, any question on this one? Okay, and let me show you how to get the 2 points of F in F. So we don't have an equation, but we have the graph, and the grid, each line has a value of 1. So down you can locate you. So x equal 2, so 2 is here, so you go up, this is the point, so this is 2, so that's point number 1, 2 and 2. Then we have 6, 3, so this is 3, 4, 5, 6, and then we go up, and that is that point. We know that this is 6. Let's see what value is that. So 3, 4, 5, 6, 7. So 6 and 7. So those are the 2 points. Use the formula, and then you got the average rate. You're welcome. Okay, we have 4 more minutes. Any another one question that might be quick? Oh yeah. Okay, so in F you don't have the equation, but you have the graph. So I am giving you the value of the two x's, x equal 2 and x equals 6. So with x equal 2 you can get that point, because you find x equal 2, then you go and you touch the graph, up or down. In this case, you go up and you find that point in the graph, and then you got the y value from the graph. The same for x equals 6. So I'm giving you x equals 6. You go here, you identify x equals 6. Then you go up, you find that point, and then you go left to find the y value. And that is how you got the second point. Did I answer your question? Okay. No, this is not the answer. We got point 1. So point 1 is this one. So 2, 2. Point 2 is this one, is 6, 7. And now we need to calculate the average rate. So 7 minus 2, okay, this is the formula of the average rate, and then 7 minus 2, and then 6 minus 2. This is going to give us 5/4, and that is the answer. Let me know if you still have doubt on this one. Perfect. Okay, class. This is we are 2 more minutes left. I think that's good for today. In 1 week, test number 1 is going to be available on Blackboard. You are going to download it from Blackboard. You're just going to start working with it. It's an open book test, so you can use your notes. You will see the format is very similar to the practice. It's exactly the same to the practice. The only thing that we will change are the exercise per se. Okay, and you will have 24 hours to complete that test. On Wednesday, next Wednesday, we are not going to meet. Okay. On Friday, we are going to start with test number 2 material. Okay. On Friday, the lecture is going to be recorded, and remember that since starting from test number 2 is where you are going to start getting information from my class to put on your project. The rubric is in Blackboard. If you have any questions, let me know. We still have almost 2 months to work on the project. 2 to 3 pages per test. Okay, 3 well-chosen examples and good writing of the topics, and identify the topics and anything that it is going to be important, anything important that is going to be presented in class goes to the project. Okay. So thank you so much for being in the class. Have a great rest of the day. I will see you on Friday.